Algebraic Reasoning, Chapter 3.4, Exercise 1 through 20. This exercise set in the book, which is actually exercise set 1 through 27, has to do with inverses of cubic functions, and which are going to be cube root functions essentially. And I'm going to do the odd numbered problems 1, 3, 5, 7, 9, and then the exercise set 11 through 15, and leave it to the viewer to do the even number problems and the exercise set 16 through 20. For exercise 1 through 4, generate the inverse of each cubic function. And so just to review, the four-step process for finding the inverse of a function is first, change f of x to y. Now in this case, we already have a y equals function, so that's really not relevant here. The second step is going to be to switch x's with y's. So I'm going to say switch x and y, x's and y's if need be. Third step is going to be to solve for y. And that's usually the longest step because there could be several steps within that solving for y. And the last step would be to take that y that we solve for and change that y that we solve for to the inverse function notation f negative 1 of x. Now obviously, because we have y, we're really going to be looking at steps 2 and 3 in this. So what we have is, I'm going to rewrite the function. So we already have y equals, so I'm going to rewrite the function as x equals 2 times quantity 3y plus 4 cubed minus 1. And so now we're going to go about the solving for y. Okay, that's step 2 already, we switched. And so I'm going to say, okay, plus 1 on both sides of this equation. So we have negative 1 plus 1, and we have x plus 1 on the left side is equal to 2 quantity 3y plus 4 cubed. That's it. We got rid of that 1. So next step we're going to do is we're going to divide by 2. Divide by 2, so we cancel out here. And we have on the left side x plus 1 over 2. On the right side we have quantity 3y plus 4 cubed. Now just kind of peeling the layers away until we get y by itself, we're going to do what is opposite of this cubed thing here, and that is going to be to take the cubed root of that. So I'm going to make a little radical sign over here, put a 3, and then consequently on the left side of the equation, same thing. And now on the right side equation, we have the cube and cube root cancel each other out, so we're left with 3y plus 4. On the left side, we have this big cubed root x plus 1 over 2. So now we're going to subtract out our 4 from both sides. Subtract out 4, subtract out 4, so we cancel. And I'm going to come over and work kind of up to the right and put down what we have left. On the left side, we have the cube root of x plus 1 over 2, and we subtracted the 4. and the right side we have 3y. Now the last thing we're going to do to solve this is divide both sides of the equation by 3. And we will have isolated y. So 3 over 3 cancel. And I'm going to do a final rewrite here. Y, I'm putting y on the left side now, equals, okay, the cube root of x plus 1 over 2. And then outside the radical, I'm going to put minus 4. And then divided by 3. So really quite a few layers to peel back here to solve this, but I hope you can see that each one of these steps in and of itself is or should not be that much of a stretch. Let's go on to the next odd number problem, which is 3. Okay, it's a similar type of problem to 1. So step 1, we're going to switch x and y. So I'm going to say x equals 1/2. Now I recommend for the viewer following along is just at the beginning of the problem, just stop the video, see if you can work out the problem, and then follow along to see if you got it right. Perhaps you're going to correct me in my mistake. In this case, I did make one. I need to switch the x and y. So that's going to be 2y plus 1. So we've done that step where we switched x and y's. And the next step we're going to do, and I'm trying to put my changes here in red. Okay, so we have on the left side, x minus 3 is equal to 1/2. We have quantity 2y plus 1 cubed. Okay. The next thing we're going to do is cancel out this 1/2. And what are we going to do that? Well, we are going to multiply both sides of this equation by 1/2. So I'll put 1/2 over here on the right, 1/2 on the left. Nope. 2, excuse me. Okay, 2. So the 2 and the 1/2 will cancel out each other. And the left side we're going to distribute. So we have on the left side now 2x minus 6. Where do we get minus 6? 2 times -3. And the 2 here times the 1/2 cancel that out. So we have quantity 2y plus 1 cubed. Okay. Now the next thing we're going to do is get rid of this cube sign by what we did on problem number 1, which is take the cube root of that right side and necessarily the same thing on the left side, cube root. So what do we have left? On the left side we have cube root of quantity 2x minus 6, and on the right side we have had the cube root and the cube would cancel each other, so we have 2y plus 1. And then the next step we're going to have is subtracting 1 from both sides of the equation. And now I'm going to bring this up here, up to the right, and we have cube root of 2x minus 6, and then we subtract 1 also, is equal to 2y just 2y, because the 1 minus 1 cancel out each other. And now we're going to solve this equation by dividing both sides by 2. And 2 over 2 cancel. And what we have left is y equals the, I'll make a fraction bar here, the cube root of 2x minus 6, and then outside the radical minus 1 over 2. And that is going to be our inverse function for problem 3. Things to look for when you take inverses of functions: your power is going to be switched, the reciprocal. So you have a cubic to start out with, and you're going to end up with a cube root in its inverse. And the minuses and pluses will switch usually. So we had this plus 3 became a minus 6 over on that side, and this one became a minus, this plus 1 became a minus 1 when we switched over to the other side. So just things to look for. And the next set is going to be 5 through 10. Determine if each pair of equations, tables, or graphs represent a cubic function and its inverse. And so there are different ways to do this. Probably what I'm going to do is our 4-step process that I introduced in problem 1. And I'm going to take that this f of x equation and see if we can end up with this g of x. And if we do, we will see that they are inverses of each other. If not, they will not be inverses of each other. So step 1, I'm going to change this f of x to y. So instead of f of x equals x cubed plus 1, I'm going to put y equals x cubed plus 1. Next, switch x's and y's. So I'm going to say x equals y cubed plus 1. And now step 3 is solving for y. So we're going to subtract 1 from both sides of this equation. So we have on the left side now x minus 1 equals y cubed. And now to solve for y, we are going to, which is step 3, we're going to take the cube root of both sides of this equation. So we get the y cubed and the y cancel it out each other. So we get y equals cube root of x minus 1. And so now we just go to step 4, which is f negative 1 of x is equal to the cube root of x minus 1. And so now we just compare. We have this function up here, g of x equals cube root of x minus 1. So we ask ourselves the question, is the cube root of x minus 1 equal to the cube root here of x minus 1? They're very similar, but they are not the same, because we have the radical on the right comprehends the x minus 1, whereas the one on the left just has the minus 1 outside the radical. So these are not equal. So therefore, we conclude f of x and g of x are not inverse functions of each other. And so we will box that in. I'm going to just box in this whole proof and conclusion. Okay, next. 6 is a similar type problem. Work through. You may find that these are inverses or not. Just look at the process. I think it'll be okay. Now we get to 7, which is a table view. Determine if each pair of equations, tables, or graphs represents a cubic function and its inverse. And so we have f of x and g of x. What we're looking for is x's and y's switch. Well, we can see that not all the numbers are the same, are represented in each. We have 16s over here on the one on the left and not on the right. And we have this negative 0.7937 on the right. And we don't see those. But we see this -1, -2, which corresponds in an inverse manner to this -2, -1. So that's one point where x's and y's switch. This 0, 0 corresponds in an inverse manner to the 0, 0 here. X and y switched. And finally, in our original f of x function, we have 1, 2, and we have g of x here has the point 2, 1. And so we have points of inverse. We have 1, 2, 3, but the other values here, although they aren't inverses of each other's, they do not contradict the others. And so we kind of have to be careful of the wording here. We say determine if each pair of equations represent a cubic function. So I'd put a little caveat since we didn't match every point up. So I'll say as far as we can tell, the functions are inverses of each other. Okay. That's one thing about tables. You're limited to the totality of your answer because you don't have all data points represented. As far as we can see, that is consistent with an inverse function. Next, 9. This time looking at a graph. Determine if each pair of equations, tables, or graphs represent a cubic function and its inverse. And what you're looking for is x's become y's and y's become x's. So the way to do this is you kind of look for key points. Well, you're seeing if you graphically are reflecting about the line y equals x. And if you see this piece, I'll call this function down below here f of x, and this one up here g of x. Are these inverses of each other? Well, to be inverse of each other, you reflect about the line y equals x. So x's become y's, y's become x's. Now you are going through the origin in each case. But I hope you can see that these seem to be reflecting about the line y equals x. And so it looks like this y equals x is a little bit off. That's kind of a graphical limitation. So we say since the functions since the graphs is a more correct way to say it, of the functions reflect about the line y equals x, they are inverses of each other. And one thing also about these functions, and you can see that for cubic and cube root functions, is that they can a lot of times be functions, and the inverses of them will be functions as long as they're monotonic. That's another piece of vocabulary. So we have the function, the one here, I label f of x increasing for all x, and g of x is likewise increasing for all x. So anyway, 10, I hope you can see that that doesn't look like an inverse function. Now we have this set for questions 11 through 15, use the graph of g of x equals cube root of x minus 1, and f of x equals cube root or cube our quantity x plus 1 cubed. So we have both of these, and we're looking at the one in red, looks like a cubic function, and the blue one here looks like a cube root function. What is the domain and range and interval notation? So I'm going to go ahead, get a little skinnier pen here. Okay, domain. Let me go back here. Okay, domain. I'll write this word out here for this can be for f of x, and it says f of x is this cubic function, so we're going to call this f of x here, right? Is all real numbers. Interval notation is parentheses, negative infinity, comma infinity. A range is likewise going to be all real numbers, which we write similarly. Greater than negative infinity, less than infinity. So that's going to be our domain and range. And I'm going to box this in. Next, 12, what's the domain and range of g of x? And g of x is this cube root function, so I'm going to write over here g of x. And our domain, I'm going to just use capital D, is going to be greater than negative infinity, less than infinity. And our range is going to be the same thing, greater than negative infinity, less than infinity. Okay, so that's going to be that one there, and problem 12. Problem 13. What is the y-intercept of each function? Okay, again, this one right here, the cube root one is going to be g of x. The cubic function is going to be f of x. And so the y-intercept of each function, we're going to say for f of x y-intercept is going to be, looks like we have 0, 1. Okay, for g of x, y-intercept is going to be 0, -1. Is that right? 0, -1. So that looks like that's good for our y-intercepts. Okay, problem 14. What is the x-intercept of each function? Again, our cube root function is going to be g of x. Our cubic function here is going to be f of x. And so for f of x, x-intercept is going to be equal to, and here's f of x. Looks like we have -1, 0. And for g of x, x-intercept is going to be equal to 1, 0. And what you'll look at in the case of inverse functions of each other is x and y intercepts will switch. Okay, so I'm just going to look at this. So for g of x, our x-intercept is 1, 0, and its inverse function is going to have the same y-intercept. It's going to be just opposite here. So it's something x's and y's will switch in these situations. So we're going to have 0, 1. Anyway, Now 15, what is the point of intersection of the two functions? Now this one here is tougher to do. Now you can just kind of look at it, and it's going to be this point right here down in quadrant 3 where these two functions intersect and touch this line, y equals x. And what is the value of that? It looks like it's going to be, you know, that the x and y values will be the same. So it's going to be negative 2 point something comma negative 2 point something. And to find that out, if you set these two equations equal to each other, we can say we can set x plus 1 cubed equal to cube root of x minus 1. Well, what I'm going to recommend for this one is solving by graphing. And to do that, we're going to set one side of this equation equal to 0. So I'm going to subtract quantity x plus 1 cubed from both sides of this equation. And so we end up with 0 on the left side is equal to cube root of x minus 1 minus quantity x plus 1 cubed. And if we rewrite this as f of x equals cube root of x minus 1 minus quantity x plus 1 cubed, and graph, we will see along the x-axis what our solution is. And I have availed myself of a TI Nspire CX calculator, and I'm going to put that function in place. So I press tab, and I'm going to put in the cube root, okay, cube root of x, come out here and subtract 1, and then we're going to subtract in parentheses x plus 1, quantity x plus 1, and come outside the parentheses and go to the power of 3. And what we're doing by this is we are arranging for the solution of the function to cross the x-axis, and where that solution crosses the x-axis will be our answer. And here we see it right along the x-axis. And I'm going to use trace for that. Menu, trace, graph trace, and I'm going to go to the left, and it's going to highlight where it is. So 0 is going to be negative 2.32, and we can get more decimal places on that if we take our hand, and this is kind of hard to do with how do we get our hand over that? Let's see if I can get a hand on that. No. Let's see if I can do that. And I have trouble hovering over that. If you get that open hand over it, you're going to be able to just hit that plus sign until you get it. Try it one more time. No, I'm unable to do that. And you press the plus sign, you get, so we're going to get negative 2.32. So our point is going to be point of intersection is going to be negative 2.32, comma, negative 2.32. And so that will be our answer for that. I invite the viewer to go ahead and look at this next set, which is similar, 16 through 20. And that will be the same questions, but over a different set of graphs. And then beyond what I have on paper would be problems 21 through 27. Good luck on this and all your other good work, and thanks for viewing.